Example 5. A man walks along a straight path at a speed of 2 feet per second. So there's your man walking. Okay, that means its distance from here to this point is x. So a searchlight, there's the searchlight. A searchlight is located on the ground 20 feet from the path. So there's that perpendicular distance of 20 feet and is kept focused on the man. At what rate in degrees per second is the searchlight rotating when the man is 50 feet from the point on the path closest to the searchlight? In other words, from here to here at the instant when x is equal to 15. So once again, we have a right triangle problem. So let's go ahead and write down all the given and what we're going to look for. Here is our right triangle. So let this be x. That's this distance right here. This is right here is the x. Okay, and then we're given that the searchlight is rotating. So this is where the searchlight is. Okay, so that's your searchlight. And then, so given that dx by dt is equal to 2 feet per second. All right, and then this is fixed, so this distance is 20. That's fixed. So now what we're given is that what we're asked for is to find. So we're going to find d theta by dt in degrees per second, and that's at the instant when x is 15. So what do you think would be our equation if these are the relationship? We've got an angle, the side opposite, and the side adjacent. So what is that trig function that relates side opposite over adjacent? Okay, so let's continue. Right, so that's given. So now we find d theta by dt at the instant when x is equal to 15. So let's go ahead and mark all these. That's x, that's 20, and then this is theta. So our equation that we're going to use is tangent theta equals x over 20. Remember, that's fixed. Okay, so now differentiating both sides with respect to time, we get what's the derivative of tangent is secant squared theta, and then multiplied by d theta by dt, because theta changes with respect to time. X changes with respect to time, so you have 1 over 20 dx by dt. Right, so now we're solving for d theta by dt. So what would get rid of the secant if we multiply by the reciprocal? So cosine squared theta, because cosine and secant are inverses of each other, so that would supposedly cancel everything, cancel both. Okay, so now what we've got is d theta by dt is equal to 1 over 20, okay, dx by dt. We already know what dx by dt, that's given right there. So now what is cosine squared theta? Right, so now we're doing a little bit of triangle solutions. So at the instant, so when x is equal to 15, then we can find what z is, because in order to find the cosine of theta, we need the hypotenuse, so that you get adjacent over the hypotenuse. So when x is 15, y is always 20, so that means we use the Pythagorean theorem, x squared plus y squared equal to z squared to get z. So z is the square root of, all right, so x is 15 squared, and then 20 that's 20 squared, and then if you look at that, that's going to be 400 plus 225, so that's 625, and take the square root, you get 25. Right, now why are we doing this? That way we can look for the cosine of the angle theta. So cosine of theta would be adjacent over hypotenuse, so 20 over the hypotenuse at the instant when x is 15 is 25, which means this is 4/5. All right, so now we're ready to plug in everything. So this is 1 over 20. Okay, dx by dt is 2 feet per second. Well, let's not write the unit of measure to avoid the mess. So let me rewrite that. So it becomes times 2 and then multiplied by 4 over 5 whole thing squared. Okay, so 1 over 10. So that's 1 over 10 times 16 over 25. So that gives us what? Well, that's going to be 8 over 5 times 25, 125. Now, what is the unit of measure here? Since this is in radian measure, okay, so that's your d theta by dt. We're not done yet because it says they're asking for degrees per second. So this is actually radians per second. So to multiply, to get the degree, we multiply by 180 degrees over pi. Okay, so the radians and radians canceled, divided by the seconds. So if we simplify that and plug in your calculator, it's approximately 3.7. Okay, so degrees per second. So that's the rate of how fast the searchlight is rotating when the man is 50 at the moment that he is 15 feet from this point to here. Right, so that answers question example number 5. Okay, example 6. Gravel is being dumped from a conveyor belt at a rate of 40 cubic feet per minute. So right away that should give you a hint that this is dV by dt. And its coarseness is such that it forms a pile in a shape of a cone. So there's the cone, and this is just, a visual aid, so you see what's going on. Okay, so there's the conveyor belt, and that's where gravel is being dumped, right there. And it creates a cone-shaped pile. Okay, it says that it's the shape of a cone whose base diameter, that's the base diameter, and height are always equal. Okay, how fast is the height of the pile increasing when the pile is 20 feet high? Let's go ahead and let this be your height, and then let this be your diameter. So what is the relationship? The relationship is that h is always equal to d. Or since d is twice of the radius, that means the height is always twice the radius. Okay, so question is, what equation are we going to use based on what's given? Well, that's the volume. Right away, this gives us the hint that we're going to use the volume of the cone, and then we're going to find dH by dt because it says how fast is the height increasing. So let's continue. Given dV by dt is 40 cubic feet per minute, and then we are to look for, so we're asked to find dH by dt. Okay, at the instant when h is 20 feet. So what is the equation that we're looking for? Okay, the equation that we're looking for is that V is equal to 1/3 pi r squared times the height. Now, here's an example, or here's an equation where you have two variables that are that relates to the volume, and we want to solve this in terms of just one variable. So what we're going to do is to substitute, or rather we let h be equal to 2r, because that's the relationship that they have, is that the base of the diameter is always equal to the height. So the diameter means twice the r. So from here, what we're going to do is solve for h in terms of r. So that means r is equal to h over 2. So now let's go ahead and substitute. So rather we solve for r in terms of h, because we want to retain the h, because you remember we're looking for dH by dt. So this becomes 1/3 pi, and then what is r? It's h over 2 squared times h. So let's see, what do we have so far? It's going to be 1 over, since this is squared, that's going to be 1 over 12 when you multiply these two together. Pi h cubed. So this is the equation that we're going to differentiate. So let's continue. So v is equal to, remember v is pi 1 over 12 pi h cubed. So 1 over 12 pi h cubed. Then remember dv by dt is given as well. dv by dt is 40 cubic feet per minute. So are we ready to differentiate? Yes. So dv by dt, that's differentiating the left side, is equal to, this is just pi over 12, then multiplied by 3h squared times dh by dt. So now the rest is just plugging in all the given. Remember, we always substitute after we differentiate. So this is now pi over 12 times 3 times, remember, at the instant when h is 20, let's go back to the problem. Okay, at the instant when the pile is 20 feet high, so that means at the instant when h is 20 feet, substitute h, which is 20 squared, dh by dt, and this is equal to 40 on the left side. Okay, so what cancels out here? This cancels into 4. Then we have 400, right? Well, that's 400 divided by 4, so it's going to be over 4 pi dh by dt. And then you have a 40 here. So that cancels out. We have 100 pi dh by dt, and then this is 40, and so carrying on here, we see that dh by dt is equal to 4 over 10 pi, and what is the unit of measure? That's feet per minute. Then we continue to simplify. That's equal to 2 over 5 pi feet per minute. So that's the rate at which the height is increasing as they dump at the instant when h is 20 feet high. Okay, there you go.